This is binary tree. Each node has value and value member. This is root node. And this node has value 17. This red arrow represents left child and left. This red arrow represents this node is left child of this root node. This blue arrow represents and right child of this root node. Okay, since this is blue arrow, this node and right of this node. Now we want to find the value 23. So we want to find this node, the address of this node. Okay. Now in this configuration, when value 23 is given, we search value 23 like this. If value is less than m value, so we compare this value with this value. We compare. If value is less than m value, then we take left child. If value is greater than m value, then we search for right child, m right. Else, if value equals m value, then we found. So I will turn this into C++ algorithm like this. We create a find function. Find function returns node pointer. Binary node pointer. This is return value. Find, it takes a parameter value. This is function body. If value less than m value, we search for value in the left node. Else, if value greater than m value, we search for value in the right branch. I would say left branch. Else means value equals m value. Then we found the node. Return this. This is basic construct of find function. So if value is less than m value, then we search left branch. If value is greater than m value, then we search for right branch. Otherwise, value equals m value, then we found the node. So we return. Now let's concentrate about left branch. We will concentrate on left branch. Okay? In case of this node, this branch is right branch. M value 23 is right child of m value 17. It does not have a left branch. This node does not have a left branch. Okay? So we have to check if the left node exists. In the left branch, we have to check mLeft is valid. Okay? If mLeft is valid, then we can return mLeft. We call this function find recursively. Find value. This is recursion. This part is recursion. Okay? Now, in the right branch, we also have to double check mWrite is valid. If mWrite is valid, then we return mWrite find value. So this function call is recursive because in this case it does not have left child. This node 72 does not have left child. It does not have right child. Okay, so we have to test mLeft, left child is valid, or mWrite, right child is valid. If child is valid, then we call recursively. We call this function recursively, like this. If mWrite is valid, then we call find this function recursively. What if this mLeft child does not exist? Child does not exist. Suppose our value is 15. Okay? We are trying to find the value 15. For example, we will compare 15 with the value 50. So this part of code is tested. Since 15 is less than 50, so this left branch is selected. This part of code is selected. In this part, we call this function again. We call this find function recursively. This function is called again. Now here, we test 15 with 17 again because we called this function recursively, like this. So if we test 15 is less than 17 in this part is called selected again because 15 is less than 17. But this node does not have left child. Okay? Please note that this blue arrow represents mWrite. Okay? Also this blue arrow represents mWrite. In case of node 17 does not have left branch, left child, so it amounts to here. In this case, we failed. Now, let's think about we are trying to find value 80. Now, this time, value is 80. We compare 80 with 50. Okay, we are trying to find the value 80. Since value 80 is greater than 50, this part is hold. Okay? So this branch is selected. In this branch, it calls this function, find function recursively. It goes to here again. Now at this point, we are comparing value 80. It is greater than value 70 in this node. That this node does not have right child. It does not exist. So we failed to find 80. So we failed. Now I will turn it into C++ code. So if M left is not valid, we have to return null PTR because we failed. The value does not exist. We can fix like this. Also in this part, else return null PTR. This is our C++ code for finding a value from a binary search tree. We can further simplify this part of code like this. If M left is valid, then M left find value, else null PTR. So this part code is simplified like this. Also in the same manner, we can further simplify this part of code like this. M right is valid, M right find value, otherwise null PTR. And we can further simplify like this. So this is our function find for binary search tree algorithm. Hi everyone, my name is Thomas Kim. Today is July 13th, 2019. This is my 55th episode about the future of C++ programming, C++ GUI standard. This is also 7th episode about the binary tree in C++ language. If you haven't watched my previous video, Binary Tree in C++ episode 6, please double click this link. My current session continues from my previous episode, episode 54, Binary Tree in C++ episode 6. If you haven't watched this video, please watch this video, then come back to this current video. In this episode, we will learn how to implement find function for binary search tree. If you start Visual Studio Code and open CPP extension folder, in the tutorials folder, you can find our previous source code 055 binary tree 06 CPP. Right click, copy, and scroll up. Select this folder once again, right click, paste. Here, right click, rename tree 7, and it should be 55, like this. Now delete this code. In this source code file, scroll down and find print usage. In this function, I will copy this part of code, copy and paste. I will change it to usage 5, and it should be command should be find, and change like this. Find value 19 from the list like this. This is binary list. Copy and paste like this. Fix like this. Now scroll down. In the function main, copy this part of code, copy, paste, and it should be find. Then here we create function like this. Binary node t ptr root find. This is binary node ptr. We find this value. If ptr is valid string, we found value ptr get, and else string we failed to find the value, and well, you can just say value. Okay, now scroll up, find function. We defined this find function before, but this function is inefficient. Okay, so I will disable this function like this. This code is inefficient, so I fixed like this. Binary node find element type value. If value less than this m value, else if value greater than m value, else we found return this. Now we fix this part of code like this. If this m left is valid, return this m left. Find we call recursively, else we failed, return null ptr. And in this part too, if this m right is valid, return this m right find value. This is recursion, else return null ptr. We failed. So we modified our function like this. If value is not found, this function returns null ptr. Now start command prompt. You should be in CPP extension tutorial folder. CL EHSC STD C++17 055 binary 307 CPP FE binary 3 EXE. Please note that we are using Microsoft compiler. Hit enter. CLS binary 3. We have UCG 5. We can try like this. I copy this function this sample, paste. We are trying to find value 19 from this list. It does not have a value 19. Now we try to find the value 10. Then we found the value 10. We try to find the value 16. Value 16 is found. Value 16 is found. If we try to find the value, for example, 11, we failed to find the value 11. In this list, value 11 is not included. If you have watched any amount of my previous videos, especially binary tree, I use recursive function call quite a lot. And when we return value from a recursive function call, the algorithm becomes very complex. And I have used this technique quite a lot in my programming career. In my future episode, I will explain how to make recursive function call simple and easy to manage. I will post complete source code to extension talkplayfun.com website. By the time you watch this video, you can click this link and download complete source code. If you unzip this downloaded file, in the CPP extension tutorial subfolder, you can find the complete source code. To build my source code, you have to install latest version of Visual Studio 2019 and also GNU G++ and Clang. So please watch these videos. Also, you have to make proper system environment variables. Please watch these two videos. If you haven't watched this video and make proper system environment variables, you may not be able to build my source code on your machine. Also, you have to watch this video and make proper system environment variables and have to create command prompt like this. Also command prompt like this. Otherwise, you may not be able to build my source code. In future episode, I will develop more advanced algorithm for binary search tree. Please subscribe to my YouTube channel. Thank you for watching.